This video covers the review for chapters 5.1 through 5.6. Find the degree of each polynomial, if possible, and classify it as a monomial, binomial, or trinomial. When looking at polynomials, the number of terms is described by monomial being one term, binomial being two terms, and trinomial being three terms. 3y to the fifth minus 9 is a binomial. 9xy to the seventh plus 3x squared y minus 7x is three terms. So trinomial describes that. A monomial would look something like 3x to the seventh. Polynomials can only have exponents of 2, 1, 3. They cannot have exponents of -1, and they can also not have exponents in a denominator, square roots on the variables. Those are all not polynomials. We only find the degree of polynomials. So the expressions that are not polynomials, we leave them alone. If it's a polynomial and it has one variable, the degree is as simple as just stating the highest exponent you see on any term. When it has multiple variables, you go through all your terms and you add the exponents. 8, 3, and this one's a 1. And the highest of those is 8. So the degree of this polynomial is 8. If you look at a binomial, like 5x plus 2, the highest exponent there is a 1. And if you look at something like a constant term, something like 5, doesn't have a variable, that's degree 0. And that's because you can write 5 as 5x to the 0, because x to the 0 is 1. Next problem. Evaluate 2x cubed y squared minus 2x squared y minus 4y cubed for x equal to -1 and y equal to -3. Go through and put parentheses where you see these variables. X is -1 and y is -3. 2 times x squared times y minus 4 times y cubed. 2 times -1 cubed is -1, and -3 squared is +9. Minus 2 times -1 squared is 1 times -3. Minus 4 times -3 cubed is -27. Two times -1 is -2, times 9 is -18. -2 times 1 is -2, times -3 is +6. And -4 times -27 is 108. 6 plus 108 is 114, and 114 minus 18 is 96. Perform the following operations. -4 times z squared minus 2z, we distribute the -4 across. -4 z squared, and -4 times -2z is 8z. -3 times 4z squared is -12z squared, and -3 times -1 is +3. Plus 9 times 2z is 18z, and 9 times -3 is -27. Now we look for our like terms. -4z squared minus 12z squared is -16z squared. 8z plus 18z is 26z. And 3 minus 27 is -24. Next problem, -2x times xy plus y. We distribute the -2x. -2x times xy is -2x squared y. -2x times y is -2xy. Now we distribute the -2y. -2y times x is -2xy. And -2y times -y is positive 2y squared. Three times y squared minus 3xy. 3 times y squared is 3y squared, and 3 times -3xy is -9xy. Now we look for our like terms. -2x squared y. I don't see any other x squared y's, so that stays as is. -2xy minus 2xy minus 9xy. -2 minus 2 is -4, minus 9 is -13. And then the y squareds are like each other, and that becomes 5y squared. The next problem, -5x to the fifth y multiplied by 7x y squared z. We take those coefficients and multiply them. -5 times 7, x to the fifth times x, y times y squared, and times z. -35, x to the 5 times x to the first. We add those, becomes x to the sixth. Y to the first times y squared is y cubed times z. X minus 7 times x plus 13. This is the FOIL property. This is the distribution. X times x is x squared, and x times 13 is 13x. -7 times x is -7x, and -7 times 13 is -91. So we combine our like terms in the middle. 13 minus 7 is 6. And we get the trinomial x squared plus 6x minus 91. 5y minus 6 times 2y minus 1. We distribute the 5y across, and that's going to give us 10y squared. 5y times negative 1 is negative 5y, and negative 6 times 2y is negative 12y, and negative 6 times negative 1 is positive 6. The middle terms combine and give us negative 17y. And so we get 10y squared minus 17y plus 6. The square of 7x minus 4. When we square a binomial, it's best to repeat the binomial twice as indicated by the exponent. Then we use the FOIL method. 7x times 7x is 49x squared. 7x times negative 4 is negative 28x. Negative 4 times 7x is negative 28x. And negative 4 times negative 4 is positive 16. The middle term gives us 2 of those, 28s, which is 56. So we get 49x squared minus 56x plus 16. The next problem says 3a minus 2 multiplied by 9a squared plus 6a plus 4. This is like the FOIL method where we distribute the 3a to all three terms. 3a times 9a squared is 27a cubed. 3a times 6a is 18a squared. And 3a times 4 is 12a. And now we move on to the negative 2 and distribute it. Negative 2 times 9a squared is negative 18a squared. Negative 2 times 6a is negative 12a. And negative 2 times positive 4 is negative 8. Those middle terms there are all opposites of each other, so they cancel, and we're left with 27a cubed minus 8. The next problem says 3x squared minus 1 times y minus 2. We use the FOIL method on this. 3x squared times y is 3x squared y. 3x squared times negative 2 is negative 6x squared. And now we distribute the negative 1. Negative 1 times y is negative y, and negative 1 times negative 2 is positive 2. So I see if I have any like terms, and I realize that the x squared y isn't like anything, the x squared isn't like anything, and the y and the 2. So that is my answer. We just leave it with 4 terms. Next problem, negative 3x squared y plus 21x y cubed minus 6x cubed y squared divided by 6xy. So for this one, we distribute the 6xy to all three terms in the numerator. Negative 3x squared y divided by 6xy, the y's cancel. X squared over x is x, and negative 3 over 6 is negative 1 over 2. So we write that as negative x over 2. Twenty-one 6. 3 goes in 21 7, and 3 goes into 6 twice. The x's cancel, and y cubed over y is y squared. minus the 6's cancel. X cubed over x is x squared, and y squared over y is y. Six y minus 8 divided by 2. We distribute the 2 to both terms. 6 over 2 is 3, leaving us with 3y, minus 8 over 2 is 4, 3y minus 4. Next problem is long division. Divide by using polynomial long division and write the answer as quotient plus remainder over the divisor. This is my divisor, and so I'm dividing by x minus 3. X squared minus 2x minus 6 divided by x minus 3. So we start with the first terms, x squared and x, and we divide x squared by x. And now we distribute the x to the x minus 3. X times x minus 3 is x squared minus 3x. And now we're going to subtract. So we subtract by changing the signs. Negative 2x plus 3x is x. And now we bring down. And now we start over again. First term divided by first term is 1. And now we multiply. 1 times x minus 3 is x minus 3. Now we subtract by changing the signs. Negative 6 plus 3 is negative 3. And now there's no more to bring down, so we write the answer as quotient, which is on top there, x plus 1, plus the remainder of negative 3 over the divisor of x minus 3. The next one, x cubed minus 5x squared minus 3 divided by x plus 3. So the divisor is x plus 3. And notice that the x cubed minus 5x squared is missing this x term. So we'll place a 0x there just as a placeholder for the x's. And now we start dividing. X cubed, first term, x cubed divided by first term x, which is x squared. We place that x squared directly above the x squareds. And now we multiply. X squared times x is x cubed, and x squared times 3 is 3x squared. We multiplied, and now we subtract. We do this by changing the signs. X cubed minus x cubed is 0, and negative 5 minus 3x squared is negative 8x squared. And now we bring down. So we divide negative 8x squared divided by x, which is negative 8x. And now we multiply. Negative 8x times x is negative 8x squared, and negative 8x times 3 is negative 24x. Now we subtract by changing the signs. 0 plus 24x is 24x, and the x squareds cancel out. Now we're into the last step, bring down, and we start over again. first term by first term leaves us with 24. So we have plus 24. And now we multiply 24 times x is 24x. And 24 times 3 is 72. Now we subtract, change the signs, 24x minus 24x. And negative 3 minus 72 is negative 75. So we write the answer as quotient, x squared minus 8x plus 24, plus the remainder over the divisor. Next example, find the area of the entire rectangle. There's two ways to do this problem. One way is to recognize the dimensions of each of these little rectangles in here. And the first one's an x by x. And so its area is length times width, or x times x being x squared. And this rectangle here has dimensions 12 by x, so its area is 12x. This rectangle here has dimensions 12 by 3, so its area is 36. And this rectangle has dimensions x by 3, so its area is 3x. So when you add all those up, to add all the areas, you get x squared plus 12x plus 3x plus 36, which is x squared plus 15x plus 36. The other way to do it is to recognize that this full rectangle has dimensions of x plus 12 by x plus 3. And so when we do length times width, or area is length times width, we FOIL this out. X times x is x squared. X times 3 is 3x. And 12 times x is 12x. And 12 times 3 is 36. So we have exact same expression now, which leaves us with the exact same answer, x squared plus 15x plus 36. And with area calculations, the units on it are in square feet. The square feet comes from every time you take a foot times a foot. A foot times a foot is a square foot. Next examples, next problems. These are our properties of exponents. When we have an exponent on the outside, we distribute it to each of these factors. Negative 2 squared, x cubed squared, and y squared squared. Negative 2 squared is positive 4. X cubed squared, those multiply and give us x to the 6. Y squared squared is 2 times 2 is 4. And notice the square of a negative number, always going to be positive. Next problem, 2y to the 0 cubed. Y to the 0 is 1, so we're just left with 2 times 1, which is 2. cubed, which is 8. Two to the 0 plus 4 to the negative 1. 2 to the 0 is 1. And negative exponents are reciprocal, so that's 2 plus 1/4. 2 to the 0 plus 1/4. 2 to the 0 is 1, and 1 plus 1/4 is 5/4. You can do that by either writing 1 and 1/4 or by converting the 1 into 5/5. Sorry, 5/5. 4/4. Because I need a common denominator there of 4. 4/9 to the negative 1. That's the reciprocal of 4/9. So we take the reciprocal and write it as 9/4. Next problem, -7 to the negative 2, or the opposite of 7 to the negative 2. The opposite is outside of those parentheses. So we take the reciprocal of 7, which is 1/7, and change the sign on the exponent. The negative is not seen by this square this time, so it's a -1/49. Next problem, y³ over y to the negative 7. The negative exponents, they move top to bottom or bottom to top, but the positive exponents stay right where they are. So y³ stays, and the y to the negative 7 goes to the top as y to the 7th. You could think of this as being over 1 if you like, but that's just y³ times y to the 7th. And now those exponents add and give us y to the 10th. In the next problem, we do something very similar to that, because these negative exponents, they move top to bottom or bottom to top. And just the exponents move. So I have negative x to the 4th, and that x squared goes to the top. 2 y to the 6th. X to the 4th times x squared is x to the 6th. And I still have this 2y to the 6th in the denominator. All right, now I'll deal with this negative exponent there, and I'll take the reciprocal of everything. X to the 6th goes to the bottom, and 2y to the 6th goes to the top. And now we square. I'm going to put the negative on the 2 and square that. Y to the 6th squared, and x to the 6th squared. Negative 2 squared is 4. Y to the 6th squared is y to the 12. And x to the 6th squared is x to the 12. Next problem, y to the negative 5 times y to the negative 4 raised to the negative 2. Inside those, we have a like base, so we add those exponents. And negative 5 plus negative 4 is negative 9. When we have a negative 2 exponent on the outside, those two multiply, and negative 9 times negative 2 is 18. Y to the 18th. Last set of problems. Simplify each expression if possible. And so this puts together the multiplication and addition. And remember, we can only add when they're like terms. But multiply anything. There's no limitation. X squared times x squared. 2 plus 2 is 4. And x squared plus x squared, those are like terms because they're both x squareds and their coefficients are 1. So 1 plus 1 is 2. X squared. X cubed times x squared. We add those exponents. 3 plus 2 is 5. But x cubed plus x squared, these are not like terms. So you can't add them. So either write that or you just say that is the answer. That is already simplified. And this concludes the video for the review material for sections 5.1 through 5.6.